I'm going to move on to question 2. So question 2 is launching a rocket or a projectile at an angle of 55 degrees. So the question says here, the first thing you have to do is draw a velocity vector diagram. So as you can see, I'm just drawing a triangle here. And we don't want to rub that out. It's going to go like this. And so we're going to label our triangle. So as it says there, a rocket is launched on a field at an angle of 55 degrees with initial velocity of 85 meters. So we can label this 55 degrees and 85 meters per second. So we've done part 1. So we can just go, yep, we've done that. Now the next thing we need to do is find the initial velocity in the y component. So what we can say is that sine of 55 degrees, and we'll zoom in here, is equal to y, which is the vertical velocity, over 85 meters per second. If we rearrange this equation, we get y equals 85 meters per second multiplied by sine of 55 degrees. Putting that in our calculator, let's just have a quick look. 85 times sine 55 equals 69.627, blah, blah, blah. So rounding this to 2 decimal places, it's going to be 69.63 degrees. Sorry, not degrees, we want meters per second. Perfect. So now that we've done that, we can then calculate the horizontal velocity, and that's using the same method, but instead of using sine, we're going to use cos. So we're going to go cos of 55 equals x over 85 meters per second. Rearranging that becomes x equals 85 meters per second multiplied by cos of 55 degrees. Therefore, if we put this in our calculator, 85 cos 55, and we get an answer of 48.75399, and it goes on. Rounding this to 2 decimal places, we're going to get 48.75 meters per second. So there we go, we've calculated our horizontal and our vertical velocities. We can actually check this, and we will check it, by some simple Pythagoras. Y squared plus x squared equals 85 squared. So in our calculators, we're just going to do 69.63 squared plus 48.75 squared equals, and then if you square root that answer, we should get 85, which we just did, so we're happy about that. Tick. So we've calculated uy, we've calculated ux. Now we need to find the time of flight of this projectile. So to do that, we need to use our equations of motion that we talked about earlier. And the equation we want to use is v equals u plus at. So that's final velocity equals initial velocity plus acceleration multiplied by time. So for this projectile, when it reaches the highest point in its path, in its parabola, its final velocity is going to be 0. So we get 0 equals u plus at. Rearranging this, we get u equals negative at, and trying to get rid of the negative a next to the t, we get t equals u divided by negative a. Putting some values in here, we get t equals, well, our initial velocity in the y was 69.63 meters per second, all over negative 9.8, which means it just becomes simply 9.8, and that is meters per second. And if we put this in our calculator, 69.63 divided by 9.8 equals, we get 7.105 seconds. So there we go, that's our next answer there. We'll come back over here and we actually haven't found the total time of flight, we've found the time to the maximum height. And so to get total time, we're just going to multiply that by 2. So we go, therefore, total time equals 14.210 seconds. I'm going to highlight that just so we've got that done. Come back over here and that's done. The last two things we need to do for this question is find the maximum height reach and the horizontal range. So to find the maximum height, we're going to use delta y equals ut plus a half at squared, which is going to become initial velocity in the y. So it's 69.63 multiplied by our time to max height, 7.105, in bracket, plus a half times negative 9.8 times 7.105 squared. Putting that in our calculator, we should get an answer of 247.36 meters. I'm going to highlight that answer and say, yes, we've done that. That's awesome. Now up to the last one, which is the horizontal range. So delta x, how far it goes horizontally. This is actually quite a simple equation. It is simply ux times t. It's horizontal velocity times time. And we should remember that it's not its time to max height. It's actually its total time. So that's going to be 48.75 multiplied by 14.210 seconds. Putting that in our calculator, we get a pretty big range, which is 692.74 meters. There we go. So that is question 2 fully solved. And we're just going to do that. I'm going to move on to the next question.